everyone. My name is Eva Portelance, and today I'll be presenting joint work with Mike Frank and Judith Dagan in this talk entitled Predicting Age of Acquisition in Early Word Learning Using Recurrent Neural Networks. So the question that we're interested in answering today is what predicts when words are acquired? Why is this interesting? Well, since vocabulary size and syntactic ability are known to grow in tandem, and since early words are pretty consistent across children, it falls on understanding what drives word learning can also help us understand what drives language learning more generally. So today's plan is to first have a brief survey of previous work. Then I'll define age of acquisition and present the data sources that we'll be using both for this dependent variable and for our predictors. After that, I'll talk about how a recurrent neural network fits into this picture. And then I'll present our predictive models for age of acquisition and the results of our comparative analysis. So first, previous work. So there's been previous work on predicting age of acquisition, but the predictors that have been used have mostly centered on properties of the words themselves, so things like the number of phonemes a word might have or its overall frequency. There has been work looking at properties beyond the word, such as the overall semantic context in which the word appears, but there hasn't really been anything looking at syntactic context beyond using weak proxies like mean utterance length. Additionally, much of what we know about word learning has really centered on nouns, and there's still much to be understood about how function words and predicates are acquired. Given that these words get their meaning in large part from the contexts in which they appear, it seems like it would be important to look at properties beyond the word for these types of words. There has been works that suggest that contextual cues like conceptual and prosodic cues are important, but one question that we still have is what types of cues that might actually exist within the linguistic context might have an effect on when words are acquired. So today we propose to look at the impact of syntactic cues, specifically in the form of sequential predictability on word learning. So the dependent variable we're interested in is age of acquisition, and the definition we're going to be using today is the age at which 50% of children are estimated to produce the word. So for our data, these age of acquisition estimates are going to be coming from the Word Bank database from Frank and colleagues. We have these estimates for 314 different words from the American English CDI, and these are calculated using the instruments of over 7,000 children between the ages of 8 and 30 months. For our predictors, we're going to be using different combinations of the following and their interaction with lexical categories. So the first that we're interested in is average surprisal, which is our measure of sequential predictability that we're going to be introducing. We're going to be comparing that second to frequency, which you can think of as predictability regardless of the sequential linguistic context. And finally, we're going to also add in some word-level property predictors that have been used in previous work. Now for average surprisal and frequency, these values that we're going to be using are actually going to be calculated using a data set that was built from the 39 largest English single child corpora from the Childless database. And these are all child-directed utterances. And so this data set that we've built contains about 6.5 million words. And in the case of our first predictor, average surprisal, so this is going to be the average surprisal of words across their contexts of use in those child-directed utterances. So in other words, average surprisal can be thought of as a measure of how predictable a word is across its contexts in the child's input. And to calculate this, we're going to be using a recurrent neural network. So this is where the recurrent neural network comes into the picture. That's going to be trained on this corpus of child-directed utterances. Now for the expected relation between average surprisal and age of acquisition, we expect a positive relation. So the more surprising, or the higher the average surprisal of a word across its context of use, the later its age of acquisition. So the harder a word is to predict, the later it is acquired. And for our second predictor, this is going to be frequency. Here, we're calculating frequency as the normalized raw frequency counts of a word across those 39 childless corpora. And with frequency, we actually expect the opposite relation to average surprisal. So here, instead of a positive relationship, we actually expect a negative relationship between age of acquisition and frequency. So the more frequent a word is, the earlier its age of acquisition. So finally, we're also going to be including these other word level predictors from previous work. So specifically, these are going to be the number of phonemes in a word, and then its ratings for concreteness, valence, arousal, and babiness. And so for specifics about how these were rated and so on, I would recommend going to the original paper by Berginski and colleagues. So to summarize, where our data is coming from, so our age of acquisition estimates are going to be taken from the word bank database. Our average surprisal estimates are going to be calculated using this childless data set of child-directed utterances and a recurrent neural network. Our frequency counts are coming from the same childless data set of child-directed utterances. And finally, our word-level predictors are going to be coming from the work of Mika Berginski and colleagues. All right, so now this brings us to our recurrent neural network. So as I mentioned, to extract the average surprisal of words, we're going to be using an LSTM recurrent network that we've trained. So LSTMs are known as good baseline models that are widely used in computational linguistics as language models. And so they've also been shown to be sensitive to syntactic information like longer distance dependencies. And how they work is that they try to learn representations for words by using the previous linguistic context in which that word appears to try to then predict that next word. So what's interesting about these models as well is that to learn these representations, actually what their objective is to minimize the surprisal of that word in context. So surprisal here is the negative log likelihood of that word in context. And thus you can think of average surprisal of a word as both a measure of how predictable that word is across its context of use, but also how difficult a word is for the model to converge on a representation for. So now that we know all our predictors and how they've been calculated, we can move on to our predictive model comparison. So in order to understand what predicts when words are acquired, we'll be comparing different linear models with different combinations of these predictors that we've mentioned and their interactions with lexical category. We're going to consider three lexical categories, so nouns, function words, and predicates. For each model that we compare, we run leave one out cross-validation over the 314 words that we have. So what this means is that we're actually fitting 314 versions of a same model on data sets in which we have held out one word that we're going to be using for test. And then the results that we're reporting are on these test words. So it's the mean absolute deviation in months across those 314 fits or words that have been held out. So for the results, so first off, we've got this null model for comparison. So this is a prediction solely based on the intercept. And here on average, we see that the predicted age of acquisition for words was off by 2.35 months across the 314 words. After this null model, next we have models with average surprisal and then frequency. And so when you look at them in comparison, we see that we didn't find the average surprisal subsumed frequency. However, if we look at this final model in blue, we did actually find the average surprisal presented additional explanatory power beyond frequency. So this is this last one here. So we also ran a nested model comparison between these last two models and did find that this addition of average surprisal beyond frequency was in fact significant. So now the question is, how exactly is average surprisal helping us predict age of acquisition? On closer look, what we find is that average surprisal is specifically helping us predict the age of acquisition for function words and predicates, but not for nouns. So if we look here at the top 50 words, which represents only 16% of our corpus, for which the addition of average surprisal beyond frequency actually reduced our mean absolute deviation, or in other words, increased fit, we see that almost all of these words are function words and predicates. So 50% of our function words are in this top 50 words, 35% of our predicates, but only 1% of our nouns. Now, this distinction between function words and predicates versus nouns is also visible in the coefficients that we have for our predictors. So for frequency here in red, we see that we have negative coefficient estimates across lexical categories. So this is what we expected to see. So the more frequent a word is, regardless of its lexical category, the younger its age of acquisition. But for surprisal, we see a positive estimate for function words and predicates, as we expected, but actually an estimate near 0 for nouns. So in other words, for function words and predicates specifically, having higher average surprisal or being harder to predict across your contexts of use means that you are acquired later. But this is not true for nouns. So why might this be? Well, linguistic context seems important to predicate and function word learning because these words require context to express their meaning. On the other hand, the nouns, as it turns out, that we have in our 314 word list are actually all rated very highly for concreteness. So they're all highly concrete nouns, which led us to conclude that possibly what's happening here is that these nouns can be learned using other cues beyond linguistic context, such as, say, visual cues like pointing or joint attention. So here are some key takeaways for today's presentation. So first off, there may be differences between how nouns are learned versus function words and predicates. Second, sequential predictability as a proxy for syntactic cues seems to be important for function word and predicate learning. And third, sequential models like the LSTM that we had here are a good tool to help us understand how function words and predicates are acquired. And with that, I'll say thank you for listening. And if you do have additional questions, feel free to send me an email at this address, so portelan@stanford.edu. And with that, enjoy the rest of the conference.